In this lecture, we're going to examine some of the different approaches that are used when sampling from a population. Just some basic definitions here always start with what's referred to as simple random sampling. And this is tantamount to conceptually to representing a population. And in simple random sampling, every element of a population has the equal chance of being selected. So this is equivalent to picking numbers out of a hat. One tool that is often used for simple random sampling that is often helpful in the research process is using a table of random numbers. And in this situation, the table of random numbers is so designed in which all the digits have an equal chance to occur. And the table of random numbers can easily be found on various university websites on the internet. Sampling with replacement is a random sampling approach in which after one unit is selected, so if we are randomly sampling one at a time units from a population of 100, that one unit that was selected has an equal chance of being selected again. So after selection, it's put back into the population. Most often in research, sampling without replacement is carried out, in which the unit that is randomly selected from a population is not added back to the population, and so it has no further chance of being selected. So each unit, if selected, is selected once and only once. In the research process, it is very often that a more systematic approach is used to select samples. And in systematic sampling, this is an approach where the researcher will first make a list of the accessible population. One example are residents in the listed 519 area code. And if the number of residents that are accessible in this population number 50,000, the next step would be to determine an interval size. And so in this case, uppercase I represents the interval size, which is the ratio of the population size divided by the sample size. And in this case, the researchers must have predetermined a sample size. So, for example, if the researchers had determined that they are interested in a sample size of 500 out of the original population here of 50,000, the interval size would be 100, 50,000 divided by 500. The next step is to randomly select a number between 0 and the interval size, which is I. That randomly selected number between 0 and I, which is 100, is going to equal a new number called K. And randomly we selected the number 41. Every 41st person in each interval now becomes part of the sample. And so the very first person that is selected in the population of 50,000 from the 519 area code, listed in alphabetical order, is the 41st person. To contact the next person, we just simply add 41 to the first number, since the number is 41 that we had calculated for K, and we add 1, and that will be 83. Then the next step is 83 plus 41 plus 1 equals the 125th person, once again listed alphabetically in the 50,000 original population. So the number of respondents per sample size, as an example, if contacting all of those individuals, all 500, only 119 respond to the request to participate in a study to complete a survey, then what the researchers have is what's called a response rate. So the response rate refers to the number of sampled individuals from the population that choose to participate in the research. And so in this situation, we have a 24% or a 23.8 rounded up to 24% response rate, which is very typical of response rates when accessing large populations to complete a survey or a questionnaire. And to illustrate the process in which step 4 is carried out, we start by counting the number of individuals in the 519 area code that are accessible, and we originally determined there were 50,000, and we count out to the 41st person that is contacted, and then starting over again, we see that the next person would be number 83. So the 41st person starts all over again in terms of finding the next 41st person, but 41 is not added to that numerical count because it would be equivalent to 0 in this situation. The stratified random sample, as the term suggests, is a random sampling of individuals from a larger population that aligns with certain groups within that population. So the population is divided into subgroups, and so some examples include males and females, or university majors. The proportional stratified sample separates the population into different categories and randomly selects a sample from each category that is proportional. And this creates the same relative number of samples in each category. And so when we talk about the same relative number, we're talking about the same percentage of samples from each group. So one example here in this course, Psychology 2360, we see that there's a total population of 300 students. 148 are focused on social psychology, 97 are focused on neuroscience, and another 55 are pursuing other majors. The goal here is to obtain 50% representation from each BA program or each BA focus. And in order to do this, 50% of students in social psychology are randomly selected, 50% rounding up from neuroscience, and 50% from other majors, once again rounding up. And so what we see here is we get that proportional representation from each of these subgroups, but when we take the proportional approach, we end up with a different overall number. And so this creates a potential problem that is addressed from a statistical analysis perspective. And so from a statistics perspective, we're dealing with unequal sample sizes, but there are statistical techniques that can adjust for the variability that sometimes is created with unequal sample sizes. This proportional sampling takes a very similar approach in which a population is subdivided into different groups, but the point with disproportional sampling, the goal is to create equal sample sizes in terms of the absolute number of samples in each category or in each subgroup. So once again, we go back to our example of Psychology 2360. We have our 300 students, 148 focused on social psychology, 97 on neuroscience, and 55 with other majors. And so the researchers in this particular study have decided that they wish to create sample sizes of 30 in each group, an absolute number. So 30 participants are sampled, are approached that are focused on social psychology, 30 in neuroscience, and 30 in other majors. In terms of the percentage of the social psychology students, 20% are obtained. 31% come from the neuroscience group, and 55% come from the other majors. And the potential problem in this situation is that the other majors group is actually overrepresented in this sample. So where we see that the number of students focused on social psychology outnumber the number of students that are studying neuroscience and outnumbering the number of students in other majors, the disproportional approach has the number of students in other majors, or the percentage of students in other majors, much higher than social psychology and neuroscience. Another approach that is used for large populations includes cluster sampling, and this involves dividing the population into subgroups or clusters according to pre-specified criteria. And a pre-specified number of clusters are then randomly selected. And then within each cluster, a random selection of a pre-specified number of participants are then made, perhaps using the systematic sampling approach on slide number 18. And so this is a map of the political ridings federally in the Toronto area. And so if a political consultant were interested in voting preferences prior to an election in Toronto, they would divide the area, the city, into these predetermined clusters according to federal ridings, and then randomly select a number of these ridings, and within each riding randomly select the residents to participate in a phone survey. When we're dealing with research participants on an individual basis, that often takes place at universities and in research labs, non-probability sampling is the most common approach. And very often a convenience sample is obtained in which participants are chosen, selected, or invited to participate based on the availability of that sample. The problem with convenience sample that researchers should always keep in mind is the bias of self-selection. So individuals that participate in research studies often have an interest in participating in research studies, and that may affect the outcome measurement that is obtained, and researchers should be aware of that. It is a very popular method that is used in order to obtain volunteers for research studies. Quota sampling uses the same approach as a convenience sample, in that the researchers will stop entering participants into a study once an adequate number is achieved. Very common approach, and oftentimes researchers will predetermine how many participants they wish to enter into their study, and there are statistical methods in order to determine what that number is. Purposive sampling refers to the selection or invitation of participants to volunteer and study based on specific criteria. And in this case, the researcher will establish what are called inclusion criteria that would qualify a person to enter a research study, and exclusion criteria. So if a person has a pre-existing condition that is not studied in the research study, they would not be eligible to participate in the study. Snowball sampling, another popular approach that is similar to the convenience sample, and that involves chain referral, where participants will spread through word of mouth the opportunity to participate in a study, and that very often helps the recruitment efforts of researchers in spreading the news that they are engaged in a particular line of study. So this ends this lecture on Unit 4 regarding the different types of sampling.